Okay, so I'm John Shuchuk. Dennis and I founded the .NET Services team along with David down here. And what we're going to do is we're going to run through at a pretty high level, do a breadth-first traverse of the technologies. And then over the course of the next couple of days, Clemens, Justin, and Mustafa will provide more detailed drill downs on each of the sessions. So our job is to kind of show you how all the pieces fit together and talk about the overall architecture.
But we're going to get into some code too.
Yes.
So you're going to see some actual moving bits, and it's going to be pretty meaty, I think.
Yep. So unlike the earlier sessions, we're happy to take lots and lots of questions during the talk. So if there's things that we're describing that you'd like additional clarification on, we've got experts in the audience with us, and we're happy to go do that. So just to put this all in a little context, we've talked about the Azure Services Platform. In particular, we've talked at the lowest level about how Windows Azure provides this geo-distributed fabric that we build these upper layer services on. And then what we're going to do is we're going to focus in on the .NET Services piece of this talk. And in particular, we're going to look at the service bus, the workflow, and the access control pieces. So to get started, let's just kind of step back and talk about what kind of the goal of the whole project was. And that's to take our existing .NET technologies, things that many of you have already worked with, things like WCF, Workflow Foundation, and so on. And we wanted to make it very easy for people to use those things without all the overhead associated with setting up servers, configuring them, keeping them running, and so on. So Workflow is a great example of that. You can take a workflow, put it in the designer, right mouse button click, and run it. Big change in the level of impedance that's in the way of you getting your job done. So we wanted to pull those skills forward into the cloud. And to get the project started, we thought we'd focus on three main areas that developers have told us are pretty challenging. One is around application integration. How do you stitch together applications, particularly in a distributed world? How do you make sure that as you're stitching these applications together, that the identities that are required in order for those applications to function safely, how do we make sure all that works? So you might have somebody in a company that's running Tivoli, IBM's identity manager. You might have somebody running AD. How are we going to make sure that those identities can work across there? And then finally, app extensibility becomes a very big deal as we have these large extensible systems. How are we going to make that easier for people? So that's where we focused. And the talk is going to go through each of the services, the service bus, the access control service, and then the workflow services that directly address each of these areas. So let's start with the service bus. Anything to add before we get going?
I'll interrupt.
Okay. Any top-level questions at this stage? We have mics if people want to just go grab them. Okay, so the service bus. We wanted to make it easy for people to create apps that could talk to each other kind of no matter where the apps were located. One of the challenges that we have heard from many people building software as a service or SaaS solutions is that when their app is running out on the internet, they often want to integrate with resources that are either behind firewalls, if you're doing something like a Skype or a Slingbox, or with corporate resources, whether it be an SAP system or directories, BizTalk. The firewalls, the connectivity often end up being enormous challenges for people that typically, in many organizations, can be a very big project to get the apps to work. Moreover, when people get those apps up and running, they often don't know all the different ways that people are going to want to connect together the app. So often in financial services, you'll see situations where there might be a stream of information, for example, stock prices, and you're getting that data feed, and there might be 10, 100 apps that are interested in that data. And if the developer producing that information had to know about every app that might want to use it, that would become a very onerous part of the project, and it would be a lot of work to keep everything in sync. So if we could make the applications more loosely coupled, that would help a lot. And then we've got all these partners or users who might be running in lots of different places, cross-organization. Can we make that easier for folks? So the approach that we've focused on was to provide a high-scale, highly available service bus, just like the enterprise service buses that people use inside of corporations. Let's provide one of those hosted up in the cloud, and we'll modify the way that that thing interacts to support open internet protocols. So we'll support REST, we'll support Atom, we'll support things like WS security, so that people can connect into this kind of no matter what the platform is that they're working with. So what I'm going to do is just run through that internet service bus pattern. We'll talk about kind of how these things stitch together. We'll look at the service registry aspects of the service bus, then talk about the connectivity capabilities, and then look at the publish and subscribe mechanisms. Then we'll go into a little bit of the nitty-gritty on the bindings, how we ensure connectivity, what some of the mechanisms are under the hood for ensuring this connectivity, and then we'll spend a minute or two talking about integration with the access control, and then we'll revisit that in the access control session. So here's the service bus application pattern. At the highest level, you see this notion right here in the middle is an internet service bus, and we can have various kinds of applications that are on top of that. We talk about things like service orchestration, being able to drive that service bus, but that service bus contains a messaging fabric, which is the thing that distributes the information down here, a service registry, which is a way to find services that are connected to the service bus, and then a set of naming capabilities so that it's easy to produce human-readable names that connect into the service bus. So we can have a nice URL that's going to give you a reference to various services that are attached now to the service bus. Then we've got the federated identity and access control technologies that are ensuring that people have control over their names, the registry, and the messaging fabric, so that as we stitch the apps together, everything is done safely and securely. So now we've got that service bus. We can plug in your service to it. We can plug in lots of different clients into it, whether those be desktop apps, web apps, phones, Silverlight applications, Flash applications. All of those things can easily connect into the service bus. Another thing that people typically connect into the service bus are their on-premise service buses. So you can take your existing ESB technology, connect it up into the service bus, so that'll enable you to work across organizations. So you might have things like fulfillment systems that are on that service bus, and now they can start being used to connect into partners. And then finally, we're actually taking our cloud services themselves, and we're attaching it to that service bus so that you can locate and use the services in a variety of ways, kind of no matter where you are and so on. So that's at a high level, the various pieces that we're looking at. Make sense? Any questions at this level? There's one over there. I'll repeat the question.
I noticed your ESB model looks a lot like the model up top.
Yeah, so that's the idea. So the question is, that ESB box looks very similar to the internet service bus, which is up above. And that's intentional. What we're doing is we're taking the same pattern that people have been using inside of corporations to create a service bus, and we're now hosting it up in the sky, and we're saying the one that's on-premise can connect into the one that's across organizations, and all the information can continue to flow through the existing service buses and across. Make sense? Okay. So any others? Yep, one more.
What about the BizTalk services?
What about BizTalk services? Great question. So many of you may have seen some of these technologies earlier. We launched and incubated the technologies that you're seeing in this talk as part of the BizTalk Services project. The BizTalk Services project now has gone into general availability as a CTP. That's what we're announcing today. And so instead of the name being biztalk.net, it was actually under labs.biztalk.net. It's now under things like accesscontrol.windows.net and so on. The Azure brand is the way that you enter into all this. And so that project, which was incubated, is now part of this whole thing. Okay, thanks. Okay, so let's go through now each of those pieces that are in that enterprise service bus. So the first thing that we have is a service registry. The service registry gives us a way to attach services that you're running into some distribution mechanism so that messages can be delivered and found for that service. So here's a concrete example. If we have an account, so this is our account, we can place services under that and register them so that people can find them. So the URL that you see above, this either an HTTP or a SB, which stands for service bus, //servicebus.windows.net, serves as the root for this registry. Services can then be attached to the various accounts under those things, and now we can send messages to those services. The service registry provides this mapping from these URIs so that we can find the services, and this is fully multi-tenant. Lots of people can have different accounts and provide this routing capability.
So concretely, I think if you take a look at this slide, and what you'll see in some of the subsequent demos is that account is just a placeholder for the solution that you're going to be able to create. So when you're creating a solution, you're going to see servicebus.windows.net, whack services, whack foo.
Where foo is your account.
Whatever you want to create, right? So, and you can hit that both through a web browser and through the API. And then once you own that segment, you can do with what you want in subsequent segments down the tree.
Okay.
Great.
So once we've got these names, now we have a way to start establishing communications channels to the services that are associated with that name. And there are two kind of main technologies that we're going to piece together in a lot of interesting combinations to talk to the services that are located at those names. One is the relay, and what the relay does is it provides a service up in the sky that we can send a message to, and it'll ensure that it's passed to that service. And that'll work no matter where things are, because you can almost always punch out through a firewall and hit that outbound port. So we'll use things like HTTP to go talk to the relay. Now, once we've found the service itself, then we have the opportunity to do direct connect. So once we've found the service, we can use the relay itself to help establish communication channels between the various endpoints that are involved in the communication. So we'll do some pretty interesting tricks with NATs and firewalls where we'll actually splice together TCP connections so that you can have a direct TCP connection between the endpoints that are then communicating across this. We also make these services available through standard web protocols like HTTP, REST, and Atom. So you can go start looking at the service bus names inside of a browser. You can see them. You can query information from that service, and it can present it back. Don Box actually showed some of that stuff in action this morning during his keynote. And finally, we make these things available through a bunch of bindings inside of .NET. So if you're a WCF developer and you're familiar with how channels work, just you use some new bindings, and it then becomes very easy to have your application use the connectivity capabilities. So what we'll do is we'll just take a quick look at how some of these things are established, and then we'll do a quick demo where we show how we can start using the combination of the service registry and the connectivity to enable this.
So just before you do that, I want to be really clear on how that direct connect works, how you might have actually seen this as a user potentially in the past. How many of the folks in the audience use Messenger, Windows Live Messenger? Ever used it before? How many people have actually transferred files to one of your friends through Messenger? You notice how sometimes it goes pretty slowly? Right? And if you can watch that status bar kind of go across, right? Well, Messenger actually runs a whole relay, a series of relay infrastructures behind the scenes. So when you're transferring that file, if it's going slowly, it's actually traversing that whole path from client to client and through a relay service. When it gets smart enough to be able to establish a direct connection, you'll see those files fly through, right? So that's effectively what we've built into the service bus, is to establish a relayed connection first, and when possible, actually just to create that direct connection between the two clients so that you get a better transfer.
So as Dennis talked about, when we start the connection, we're going to use that relay, and we'll use that to find the services that are referenced through the name. So here's a quick example. We've got a service bus name called sb:/servicebus.windows.net services user service endpoint. That's the name of it. We start sending messages to that. It traverses a node in our relay, and now the receiver picks it up. Once that's established, we can then use the relay again, to now start sending information about where that endpoint, that receiver, is actually located. So one of the things that we can discover is what the outbound port would be, for example, on a NAT or firewall. And once we know what that outbound port and IP address is, then the sender can start sending to that location, and we can start to establish this direct connection behind the scenes. So in a sense, what we've done is we've taken those same techniques that are in Instant Messenger, and we've packaged it up into a collection of classes that are now available to any developer. So to demonstrate that, why don't we put together a quick sample showing
Sure.
A really simple web service, which is the classic Echo sample.
Great. So what I'm going to show you now is actually one of the tenets that we started thinking about when we built this team, which is if you're familiar with the .NET framework, using the cloud should be really simple and really easy. So what I'm first going to show you is actually how you use standard Windows Communication Foundation, WCF, with a binding called basic HTTP. And then I'm going to show you the changes that you need to make to use the cloud. And we're going to send messages back and forth both on a local machine and both through the cloud. So let's start first. Quick overview. Here's the contract for Echo. As you'd expect, it takes a string and returns a string. The program for the service is pretty straightforward. We create a service host. We say, hey, we're waiting for messages, and we just wait for them, basically. Here it is, at that address, at that URL. So the program, as you'd expect, effectively just opens a channel factory, which is a client code, goes and continues to send messages until we get an empty string, which is found here. So the best way to demonstrate this is actually through a little demo. So if I run the service here, and we'll get a crash. Let's try this. And still crash. Wonderful. Application endpoints. So imagine that worked. Now let me show you the magic of the service bus. This is why you got to be using the cloud. It works a lot better, hopefully. So we'll see here in a second. Very similar pattern where we're opening a host, but instead what you'll see is now we're listening at an address. And this address, as John mentioned, is service bus : this host name, which happens to be something that we put in there, and then the actual solution name. So the solution name was that user account that we talked about before. So we didn't actually have to change. If you take a look at the contract, same contract, and the implementation would be the same in the client as well. Let's see if the cloud is friendlier to us. Contoso. And we'll see if we can get the client to come up. I want to connect now to Contoso because remember, we need to be able to specify the endpoint that we're both opening at and where we want to send a message to. So we hit Contoso, and I can send text to the service. So instead of it being local on the machine, my machine obviously didn't work in that case, we're actually sending messages now through the cloud, and we're traversing any NATs or firewalls that happen to be sitting between us and that endpoint.
Okay. So any quick questions on this piece? Did everybody understand what the local echo sample is? Just the most obvious WCF class. It just does the echo, no security, just direct. And then what we showed was now the service bus being used as the intermediary. And this could be used across companies. So the client and the service could be in completely different places. One could be running at home, the server, and then you could be on the road and you could hit that even though there are firewalls in the way. So any questions on this particular piece of technology?
Okay. I want to do multicast.
Oh, got one. Yep.
Is there a guideline that you make available for facilitating a direct connect, or is it just going to be falling back to a relay and whatever else?
So the question is there going to be a guideline for what you need to do to ensure a direct connection? And if it can't do a direct connection, what happens? So we have a bunch of different bindings. One of the kind of bindings will start with a relayed, and it will attempt to create a direct connection. If not, it will fall back. You can also specify that I insist on a direct connection. And obviously, if you're in an environment where that direct connection can't be established, then that will fail. So if you were doing, as a concrete example, maybe a lot of streaming media playing videos off a home server, you might not want to pay the expense associated with traversing the relay all the time. So you might insist only support it if we can establish that direct connection. So you'll have the ability to control that by your choice of bindings and parameters on those bindings. Okay?
Great.
Question over here?
I observe that you're using the URL as sb://. Is SB a new protocol developed only for cloud, or has it already been made?
So the question is SB:, a protocol only for the cloud? So we use that as a way to identify that we're using the service bus protocols, and it gives us a way to abstract the specific connection mechanisms that are being used behind the scenes. So it might switch, for example, to using TCP behind the scenes, and that's a way to indicate that this is an abstract protocol. We also support HTTP, in which case we'll literally use HTTP. We'll do an HTTP GET or POST to go get that information, and then we'll traverse using all industry standard protocols.
So will a Java client understand my implementation of the .NET service that I've implemented in the cloud?
So the question is, can I have a Java client do this? And one of the things that Clemens will show at 10 tomorrow, is that right, Clemens?
That's Thursday.
Thursday, he'll actually show the Java clients using the mechanisms that we provide in order to do this traversal. So we provide support for that. Now, some of the most advanced capabilities, for example, some of the tricky firewall traversals, you'll want to have libraries in Java to help you do those manipulations of the NATs and firewalls, because that's pretty complicated low-level network code in order to get that to happen. And so we have open source projects that we're working on with the community to go provide that connectivity. And you'll see some of that in his talk. Does that help? One more question?
Service bus helps in connectivity and collaboration. And live mesh, where it comes into picture, how they...
So the question is, how does live mesh relate to the mechanisms that we're seeing here? So live mesh introduces a very user-centric model for connectivity. So in that model, there'll be a user that might have a bunch of devices and you want to communicate and send messages. They actually use these same underlying relay technologies that are involved here. The way I kind of think about it is we have different programming abstractions at different layers in the stack. The mesh system pulls together a whole bunch of classes into a very user-centric, a particular style of doing communication. The particular style of app that we're creating with the service bus is a very WCF, message, channel, app-to-app communication pattern as opposed to program-to-user communication model. But they share much of the same underlying infrastructure at the communications layer. And then as we go down to the next layer, which is the Windows Azure layer, we're going to be running on that same scale-out underlying compute infrastructure. Does that help? Okay, great. Any others? Okay. So let's now talk about one last important feature in the service bus. Once we've got this ability to create a name and to get messages to it, we can also use that to provide a high-scale connected multicast or publish and subscribe kind of model. And here's the idea. You can have lots of different applications that are interested in events that are occurring, and then you can listen to those events from those applications, and the service bus will fan out the distribution of those events to all the listeners. So again, classic pattern that people use inside of enterprise service buses. We're now applying that to internet scale and distribution. Over time, we're going to be extending the initial connected multicast model to support things like Anycast, which is pick one of the listeners, or add the ability to do reliable multicast so that we can ensure that everybody who's listening get the message. That involves additional buffering. And so there'll be more connectivity modes that are applied to the publish and subscribe capability. But to start, as long as the listeners are online and ready to go, we'll get those messages out to them and delivered. So let's take a look at the basic model here, and it's not really that surprising. What we're going to do is we're going to build on top of the one-way messaging capability of the service bus. We'll add some new bindings, and now the sender can send WCF one-way messages to multiple receivers. You don't really need to worry about any of this stuff. From within your code as the sender, you're just simply sending a single message to an endpoint. The service bus then is responsible for the fan out. Similarly, on the receiver side, you don't need to know that there's all this infrastructure out there. You simply listen to that name and you get the message. So why don't we take a quick look at some code that shows how to do that. Oh, don't shut off the machine.
All right, so actually what we're looking at is a multicast sample. And this multicast sample is exactly what John was describing earlier, where we're going to have multiple clients listening to a same endpoint and be able to send and receive messages. The most easiest way to think about this is if you were ever an IRC user. Did anyone ever use IRC or continues to use IRC? Remember, you would join a chat room, right? And people would send messages to that chat room. If you think about it, it's very similar to what a multicast pattern is. So what I'm going to do is actually quickly walk through the code. The first thing we want to do is understand kind of what we want to call our chat session. And then we get the solution name and password, which we use to actually authenticate with the service bus. And we use that with the access control system, which we'll talk about shortly. So here you can see we're actually going and specify the credentials to use the service. And then some of the kind of advanced features that we were talking about earlier, we actually figure out the connectivity mode that we want to enforce in this application. And depending on that, we're going to do a couple of interesting things. One of the things that you'll see here is that, to this gentleman's point earlier, here you can see that we're using HTTP as opposed to the service bus endpoint, depending again on the binding that, or on the configuration that we're using. Let's get to the app code at this point. Here's the address that we're going to listen to. Again, standard WCF code where we create a host. And now this app is both a host and a client, right? It's going to be listening for messages and sending messages. And then here's the app logic. Effectively, while there isn't a string, or while there isn't the empty string, go ahead and send messages to those endpoints. So what I'm going to do is spin up a few instances here. So let's call the chat session PDC Rocks. I'm going to use Contoso, our favorite app, Contoso, spelled correctly. We'll get that one going. We'll create another one, PDC Rocks. We'll call Fabricam, which I have amazing difficulty spelling for some reason. And then we'll create another one called PDC Rocks, Litware. Oh, we would have gone to a completely different endpoint. Let's go. PDC Rocks. Solution name Litware. PSS. Oh, I almost told you my secret password, which you'll see in a few seconds here. So if we take a look, you can see a couple of these windows coming up now where it says here are the various folks who have joined. So if I say, hey all, you can see that they all get the messages. And if I say, what's going on? They continue to get those messages on all the different clients, and each one of these windows can be a completely different machine on a different part of the network, behind a NAT or a firewall. So this is that pub sub or multicast pattern that we were talking about earlier.
Yeah, now the interesting thing about this, just flip back to the code. You know, if you've looked at something like the IRC code base, it's actually a pretty hefty piece of code. It does all that NAT and firewall traversal. It's got various servers that are up in the sky in order to do the distribution. As you can see, the code for doing this is actually quite small. And essentially what we've done in about, 30 lines of code is created the equivalent of an IRC. But again, our focus here is app-to-app communication. So we've got the Litware app talking to the Fabricam app, talking to the AdventureWorks app. They can all be sending messages to each other, listening, creating whiteboards, whatever it happens to be that's important to your application in order to do the distribution. The other great thing about the model is that it scales out. You can go from 2 or 3 listeners to potentially tens or tens of thousands of listeners. So you could imagine that you start as a small company and you might be distributing some information. Perhaps it's stock information, perhaps it's auctions. That information can be sent to your initial clients, and as your company grows, you don't have to bring on more servers. We'll scale out the server for you, and we use some pretty sophisticated techniques behind the scenes to do the appropriate high availability routing to make sure it gets out to folks. In fact, we've got a talk at the end of the day, Thursday, that goes under the hood and looks at some of the routing techniques and so on that are involved in getting that fan out to happen. Okay, so let's
We're
see.
already there.
What?
We're already there.
Oh, sorry. All right. So that gives us, again, just a quick view on the Internet Service Bus pattern. We talked about the registry, this naming, the connectivity, the direct and relayed connectivity, and then the publish and subscribe mechanisms. Let's spend a minute just kind of going under the hood looking at some of the pieces that are available and how we make some of this stuff happen. If you're familiar with WCF, I'll just spend 1 second on this. If not, don't worry about it. We've got a lot of different kinds of bindings in WCF that allow you to control the nature of the communication that goes on between the endpoints in your application. So we have, for example, basic HTTP binding, which is the equivalent of the classic web browser GET capability. You can take those bindings and replace them through config and so on, and you can get additional kinds of characteristics. So for example, the net TCP binding gives you a high-performance TCP-level communication channel, and the ability to just add those bindings changes the characteristic of how the messages are passed back and forth. With the service bus, what we've done is we've introduced a new collection of bindings that use the service bus to enhance the connectivity between the applications. And they correspond to their counterpart in the kind of local case. So just like there's a basic HTTP binding, we have now a basic HTTP relay binding. So in your code, you can swap that in. You'll add some additional parameters like the credentials that are necessary in order for that binding to work. And then it's just a plug replacement. So literally, without any code changes, you can do some of these things in config. You could take an app that's running on one of the existing bindings, go into the config, change the bindings, set the right parameters on it, and it'll work. Okay. Any questions on that? Nope. All right. Now, one of the questions that we often get asked is, wow, so if I'm in an environment where I've got a lot of clients using these mechanisms, am I going to start to overwhelm my corporate resources in terms of the ability for the routers on the edge of the network to efficiently do this? There might be lots of open connections there. So one of the things that we do is we don't try and have every client start polling and put a large amount of load on the firewalls and the routers. Instead, what we've done is we've created a short-term message buffer that can collect up the responses for the various different clients, and then the receiver opens a connection to that message buffer, this volatile buffer, and then it will pull those things off and vector them appropriately. So essentially what we're doing is we're compressing the channel down so that we're just keeping the number of connections small. Now, the message buffer technology we have makes it much easier for people to attach other kinds of clients like Java clients, PHP clients. They can use that mechanism in order to get this to all work. And over time, we expect that message buffer won't just be something that is non-durable like it is today, but we'll start providing additional durability characteristics on those things and expand the set of capabilities that we have in the service bus. Anything to add? Okay. Couple comments on access control. So this is great, right? We've got these apps that are all starting to communicate. Well, that can sometimes worry IT staff. Like, well, are you really doing the right things from a security standpoint? How do we know that this isn't going to introduce additional vectors inside our organization? And it's actually kind of interesting how we do this. What we're doing is we're attaching additional security tokens to the message, and I'm going to go into this in more detail once we've covered the access control service in a little bit more detail. But we're going to compose the message of multi-part security tokens so that one security token is used to determine whether or not somebody has the ability to send or listen across the service bus. And then you can apply additional security semantics that are application level semantics to ensure that there's an end-to-end channel that is encrypted for your application. That way, even though you might be using our relay, your app data is completely secured between the endpoints, and you can use our relay to help ensure that only those messages that you want to come in are allowed to come in. So in a sense, what we've done is we've provided you with a defense in-depth mechanism that's even stronger than the typical thing that is just on the outside of your firewall. In other words, Microsoft's going to be out there looking at the messages, running the access control service, and making a decision before it even lets something go down the pipe about whether or not that's something you want to look at. And then you can use your own security to decide whether or not to go authorize that message. And again, we'll see that in just a little bit more detail. So that's if you want the ability to secure this. And as we talked about, we started incubating a lot of these technologies out at BizTalk Services, labs.biztalk.net. And one of the features that was very requested by developers was the ability to support this new unauthenticated send option. So people wanted to use our service bus to establish an endpoint so that their services could be anonymous. And then messages sent to that look just like ordinary web requests. And they become then responsible for doing the security on it. But this is a way for you to go project out onto the internet your services and get a degree of control over who does what and how it all works. Does that make sense? Okay. So any questions on these last parts? And we'll switch over and talk about the access control service. Yep. So what parameters control who can send and receive to an endpoint? Oh, well, so there's who can send and receive. There's also security about who can subscribe. And oh, we are not doing any content-based routing up here. This is purely a topic in a topic space, and then people can subscribe or not to that topic. There's nothing that precludes you from doing content-based routing on the messages, but we don't know enough about your messages to decide how to go route those things. Okay?
We've got 20 minutes.
How does our system scale compared to TIBCO's services? The TIBCO services and our services are in pretty different spaces. TIBCO does a fantastic job at things like real-time delivery, very, very tight communication channels. They're often used in the financial services industries where it matters how, what the window of delivery of the messages are so all the clients can get them at a particular point in time. We're not trying to address that market. We're trying to address general internet-level app-to-app communication, potentially at very high levels of scale. So we build this ring-based structure behind the scenes so that we can deploy 1,000, 10,000, 100,000 machines to get these messages out and delivered to people. But we're not making any of those same kind of message time delivery guarantees or simultaneous delivery characteristics that TIBCO does. Now, what some people have considered doing is using a TIBCO bus inside of a corporation and then using this as a mechanism to get connectivity to those things because we provide that to be easy. And in fact, it's a pretty interesting scenario that people have talked to us about.
Hey, John.
Yep.
We got 20 minutes.
All right. So let's get going.
Summary.
Summary, I think we've covered all this. Let's do the access control service.
Great.
So when we build these distributed systems, there's a lot of different identities that are out there. We've got internet identities. We've got organizations that are running Sun or Tivoli or Oracle directories, Active Directory, Microsoft Services connectors. How are we going to make sure that we can make our apps work with all of our partners using all of these different technologies? So clearly, standards is going to be super important to get that to happen. But the semantics, even when you use the standards, are tough. And so what we're doing is we're going out there and we're partnering with all of these other companies and we're testing these things to make sure it works. So in Kim Cameron's talk, in the access control talk, he showed how we're able to interop between our Geneva technologies and Tivoli as just one example of the kind of work that we're doing. That's one big challenge that developers face where the access control service can help a lot. The other thing is that if you look inside of most applications, access control logic is often strewn all over the place with special case checks, particularly if you're a service provider working in these different environments. There's special case checks for this customer with groups and so on. What the access control service allows you to do is factor out that access control logic, put it into a centralized place where you can look at it, reason about the rules, understand what's being offered, and it gives you a lot of agility because now you can quickly change the rules and see it happen. That agility means that you're not going to get stuck. It means that you're going to be able to be compliant with Starbucks or whatever it happens to be, and it avoids a lot of the dead ends that people typically find when they go hand write much of the security and access control logic. So our approach was to automate federation with a wide range of providers that are out there and do that testing. We then factored the access control logic up into a rule system, and then we provide a very easy-to-use development framework to make this possible. So let's take a look at the model that's used. So if you've got your app, that's the relying party, and you've got a requester, we're going to use the access control project to help stitch those things together and make sure that the right thing happens. So the first thing that you're going to have to do in order to get that all set up is you're going to do a certificate exchange so that we know who the two parties are, and you're going to establish trust with the access control project. Once that's done, you're going to then go define access control rules up in this hosted access control project, and then that's going to be used by the requester to get the right kinds of claims to access your project. So what it will do is it will send some initial claims up to the access control project. The rules will run. It'll map input claims to output claims. That'll result in a token that goes back to the requester, and then they can use that to send it to the relying party. This is a very, very flexible model. To our knowledge, there are no access control systems that do more than this. It's, in a sense, a theoretically complete approach to identity and access. It supports RBAC models. It supports many different kinds of computational approaches that people have taken to security. So that's the basic model. It's pretty easy to do. We're going to see an example of that in just a second. So what I'd like to do, the relying party checks the claims, and that's how we decide to do it. So how do you go use this thing? Well, the hosted access control service has a website and web APIs. You define and manage application scopes. Those are where these rules are going to live. And then you define rules. Those rules can be chained. We talked about the input to output claim mapping. We can define new types of claims. We can manage the various credentials that are used by the relying party and the requesting party to sign things. And again, this all works in a way that's very standard. So we use, for example, Sun's libraries to go test against these things. So let's see a quick example of this thing in action.
Dying to show this. This is, I think, one of my favorite demos that I'm going to see or present at PDC. So let's take a look at that portal where an application has actually delegated its access control rules out into the cloud. So I'm going to log in now to this access control system. And in a second here, I'm going to go and start actually managing those rules that John was talking about before.
So these are the application scopes, in this case for the Litware application.
Yep, and we have actually two rules. The first rule is that if they're a domain user at Contoso, then we're going to say that they're a Contoso employee. And the second one's actually potentially a little bit more interesting, which is that if they're a manager, then they're allowed to actually access the application. Right? So from an end user's perspective, this is what's going to happen. Corey, who's a user at Contoso, is going to want to go and take this training. So yesterday, if you were in a session, Litware is a company who offers quizzes. Contoso happens to be a company who's hired Litware to issue HR compliance training. So Contoso wants to use the identities of Contoso within the Litware app. So here what we're actually doing now is logging into the Contoso domain. This is the domain that Corey's a member of. And she's going to try to sign in, and you can see that her access was denied. So there's a couple of rules that got executed out in the cloud, and the app realized that, nope, you can't have access to the training. You're not quite yet a manager. So what we're going to do now is play the role of an IT administrator at Contoso, and we're going to promote Corey. This is why I like being an IT guy, because here's the managers at Contoso. I'm going to go add Corey. Congratulations, Corey. You're now making a bunch more money. So now Corey's like, great, I'm a manager, I think I am. Let me go see if I can log into this system. Notice, I didn't change any of the rules in the access control service, right? So I'm going to try to log in. It's using the credentials that I had signed up before, and now I get training right away. So I didn't have to change. All I did was I changed the Active Directory in the back end. So this to me is actually a really cool demo. And I don't know if Jerry was cutting his toenails or not.
Okay.
Okay. So that's the kind of the power of the cloud and Active Directory locally. We took Corey, who was this user at Contoso, made her a manager. There's a rules engine that executes in the cloud. She came in and said, yep, here's my credentials, and now she was able to access the app.
So can we take a quick look at what we had to do in the code in order to get this to all happen?
Sure, absolutely. So here's the actual application code in Litware. Login page.cs. Pretty straightforward. Here's the login page.aspx that we had. And we're taking a set of claim identities. And if there's an identity there, we're going to use a Boolean here to interrogate the actual claim collection. So here's a collection of claims, and we're going to enumerate them. And if the value is allowed, we're going to set this Boolean that we had described here. Then we do just a little bit of additional logic where it says, if they're allowed, go ahead and redirect them to training. Otherwise, set that error label text equals access denied. So this was as complex as my app had to be in order for me to do identity and access control.
Now, in this example, we're saying, hey, we want the claim allowed. Now, we don't want just anyone to be able to make that claim, so we had to go config the system. Why don't we show that too?
Sure. So in the access control portal, I think that's what you're looking for?
No, in the web.config where we say
absolutely.
what
so yes, this framework or this code is using a library that's actually described here in the Microsoft Identity Model. So you can see here that this app is listening for tokens that are issued by this security token service.
And that's really the key. What we're doing inside this app is we're saying, I trust my particular solution up at the access control service to issue tokens that I trust. We establish that trust, and now as long as that service comes back and says it's allowed, we're going to let the app go through. And that's what gives us a lot of power. We can go change those rules dynamically without changing a single line of code. We can go modify group memberships, all of that stitched together and provide access to this. Now I could take the same app, which is running with Contoso, and if I wanted to add a new company to this training, what would I need to go do? I'd simply go to the access control system. I'd look for a new type of claim from one of our other partners, let's say Fabricam, and I would say they have access to it. All just changed. The app just now works with new partners. We're good to go.
But you know what, John?
What?
We're not going to do that.
No, I know we're not going to do that.
Because
we actually have 10 whole minutes.
I know.
So, and we've been doing questions along the way. So are there any questions on the access control service?
Great.
We got one over there. Yeah, so the question is, what identities are supported in the access control service? Well, we use an open model where anybody who supports some industry standard protocols, in particular, the protocol that almost every directory product out in the world supports is the WS Trust protocols. So that works with Sun, that works with Tivoli, that works with the Oracle products. So almost every corporate directory works. We're also at the PDC announcing support for OpenID out, That's something that we anticipate adding to our service as an inbound capability over time. That's not something that's in there today. WS Trust is in there today, but we're very flexible with respect to how those tokens come in.
You could think of the access control service effectively as just being able to aggregate various identity providers. So an additional one that, if you were in the talk yesterday, and I'm happy to show you subsequently, is Windows Live ID.
Yep, so we support that one as well.
Yeah, so if people want to use Windows Live ID, that's how they project their identities. We can integrate with that as well. Okay. Gentleman over here, I think you have a question. Yeah.
Framework is doing to implement this as the server framework?
Yes. Yeah,
Yes.
His question was, if I were to implement this, is the code that I'm basically looking at the Zermat framework? That's correct.
Yes.
Yep.
So the Zermat framework, just so everybody knows, has been renamed because it wouldn't be easy if we kept the same name for more than a week. That's now known as the Geneva framework. And the Geneva framework has a server, which is the next generation of the Active Directory Federation server, and an associated set of .NET framework libraries. That's actually the code that we were just running. We were running the Geneva framework that integrates into ASP.NET. So if you're an ASP.NET developer or a .NET programmer, using this stuff is very, very easy to do. Okay? I thought I saw one over here. Yep.
So one of the few holes here is integrating with externally available services that are not .NET and can't be rewritten. OAuth is one approach to that. You mentioned OpenID, or maybe you speak to OAuth.
So the question is, do we support OAuth? So we've heard that request as one of the other protocols that people would like us to support, and certainly I see Justin back there. That's one that Justin and I have been looking at. We think that one might be an interesting one to support. So that's why we're doing this CTP. We want to get feedback from customers about what they want to see. Okay.
I'm sorry.
OAuth.
The question he was asking about is, do we support OAuth as one of the identity providers that we could aggregate? And it's definitely like...
Yeah. Now, OAuth is a little bit different layer in the stack. OpenID is about... So we support lots of different identity providers. OAuth is about how that access control service would provide tokens off to the relying parties. Okay. So let's see. We've got about 10 minutes to the... No, we've got a total of...
Just keep going. When
no,
people
we
leave,
got
then they're
plenty
done.
enough time.
They'll be done.
No, there was 1 hour for the talk plus 15 minutes of questions, and we're taking questions as we go.
All right. I don't know. Is that a good deal? Is it okay if we run a little bit over because we're taking questions?
No, there's no over. Dude, I thought we had till 4:30.
All right, fine. Keep going. This is what it's been like.
All right, so.
Can you tell we've been working a little close together for too long?
Okay. Well, let's spend a minute talking about end-to-end security, as we talked about. Here's the access control service. We've got a kind of funny name on here. This is ac.w.n. That's an abbreviation for the access control.windows.net service. So that's the security token service that we've got up there. And here's a target service. What we wanted to show here is just a high-level diagram depicting how we're packaging up the different security tokens that can be used in this communication. So when we talked about the service bus, we said, not only are we going to do authentication of the packets through the relay, but you can do your own security end-to-end. So here's the target service. The target service has a policy. And in this particular case, it's saying, I would like to have credentials that the access control.windows.net applies for the relay, and it's going to have its own security token headers. And what that will do is that will cause the client, after it reads this policy, to acquire a token from the access control service, and it can attach its own WS security header for the end-to-end pieces. The relay will pick off the relay token, and then it will transmit the message through with the end-to-end security. Only point here is we've got a great deal of flexibility in terms of helping ensure a safe, secure connection through the relay, and then we provide you with the ability to do your own secure end-to-end communication so that we have no way to look inside any of the messages. Okay? Any questions on that? I think it's a pretty straightforward idea. Yep? How does the client get the relay token? It goes to the access control service and says, I am so-and-so. could you give me back the claim that lets me traverse the relay for this particular address?
So there's an interesting nuance here, right? Which is that the relay, in order for you to, so the relay is just another example of a service that you could have written. So
And it's in turn using the access control service.
So we've composed these two services together so that in order for you to use the relay or any other app, you need to get a token from the security token service, the access control service.
Yes, so the question is, are we really using 2 tokens? Absolutely. There's one for the relay and one for your app. We'll pick off the relay one, and we'll transmit the one for the app all the way through end to end. Okay? All right. So the access control system, flexible, rules-driven access control, supports a wide range of identity providers, as we talked about. We use the Geneva framework as the programming model. That makes it super easy to integrate into ASP.NET and other technologies. And we test this with other frameworks like Sun's Java Metro technologies to make sure that we're sticking with the standards and this all works. And again, I think, Justin, you're going to be showing some of that stuff? Great. So Justin has a talk on Wednesday at 3? Thursday at 3. Wednesday at 3 on the access control service. Okay, last service, the workflow service. A couple of key challenges that people face in the workflow area. One is workflow is a tool that lets developers go create long-running processes. They can describe how those processes work. And as we've introduced this, one of the things that developers have come back to us and said is, hey, we'd like to be able to nest these processes, make them more modular, and so on. These things are quite easy to describe, but in practice, they end up being a lot of work to run and keep running for a long period of time. You have to set up servers, you have to go scale them out, you have to make sure that as you do upgrades, that the business processes that are in flight while the upgrade is going on don't get lost, that we don't lose state, that as machines go up and down and as we add more things to this, that the system keeps running. And so even though we've got great design tools and all of those things, people have told us that's one of their biggest challenges using technologies like workflow. So when we step back and we look at what's been going on with the Workflow Foundation, we've done a lot of work on the tooling, and we have some nice designers. We're making increased investments in those things. We have a rich set of activity libraries that people can use. And the Windows Workflow runtime has run on a number of different hosts. So historically, people have done that directly into their application. At the PDC, we introduced the new Dublin technologies, which give us an IIS WAS-based set of app server capabilities. So that's out and coming. What we're going to do is focus on the services-based host, which is the workflow service. That's going to allow us to take one of these described workflows, place it out into the cloud, and execute it on your behalf. Now, Dennis is a real expert in these things, so if I dropped anything here, he was one of the guys that designed that. No comments?
No comments.
Okay.
I'm trying to burn through this.
All right. So we've got a portal up at workflow.ex.azure.microsoft.com. The easiest way to get there is just go to azure.com, and there'll be appropriate links. You can put workflows up there, manage them, the types, as well as the instances. And we've got the ability to control all that stuff programmatically. So you can use web service APIs to create, manage both types and instances. You can use these workflows to go orchestrate services, whether they're inside your organization or by using things like the service bus and composing it with the access control. You can give customers access to these things, work across organizations, and so on. So the basic model is pretty straightforward. You design a workflow using whatever mechanism you want. You can use our designers. You can generate XAML programmatically. You can use the new Azure activities, or you can use a subset of the existing Windows Workflow Foundations, those that make sense up in the cloud. You then deploy those workflows. We validate that they make sense. You then create the instances and watch how they run and see them in action. So here's the basic model. You might be using the Workflow Designer. You can extract the XAML for those things. put it up into our portal. That's the manual kind of way to do this.
And there's 3 ways of doing that. You can do it through the portal, through the APIs,
Yep.
which supports that SOAP web service, and actually through the tool.
Yep. And the third way, well, the fourth way, I guess, is the easiest, which is just right mouse button, click, deploy a workflow directly from the design surface. So when you've done that, now your apps and services can connect into those things, and the workflows themselves can be using things like the service bus to get events, generate additional events, and so on.
You know what I really want to do?
You want to show the demo?
I want to show the demo.
Let's show this demo then.
Okay, great. So here we go. As John mentioned, this is a pretty compelling or a pretty interesting demo. Here what we're actually going to do is take a look at one of the workflows that I've written. If you've used Windows Workflow Foundation, you're probably familiar with the toolbox. Here are the set of activities that you can use in .f3.0, and here's a set of custom activities that we've actually gone and written. Now, this specific workflow does something that's pretty interesting. It's going to ping a service, in this case, Microsoft.com, and it's going to do one of 2 things depending on if it's up or not. If it's up, it's going to send a message out onto the service bus. So we're actually going to spin up an app to listen to messages that are being driven by this workflow. So I have this developer experience here. There's a couple of ways I could actually get it up into the cloud. I want to make sure that you guys can get to your 445 if you so desire. So I'm going to do the quickest and I think one of the most compelling ways of getting it. I can right-click on the design surface and I say deploy workflow.
Hold on, I have to stop you.
Yeah.
So as you can see, the session goes to 4:45,
Yes.
and then they have 15 minutes after that. So you can relax.
All right.
Don't panic. Everything's okay.
I just like things running on time. So workflow type, let's call this running on time. And the solution name, we'll go ahead and put in some credentials here.
Dennis likes to do everything fast. So
Apologize. So deploy and run. We're now taking this type, we're pushing it out into the cloud. The type has been defined, and we're going to say, go ahead and run that thing. In this watchdog, let me close this guy. If I go to the multicast sample, I'm going to run that again, and I know right now that events are being raised in something called watchdog. So I'll use Contoso. And in a second here, what we're doing now is listening for messages that the workflow happens to be sending. So the workflow is pinging Microsoft.com. It's going to say, is Microsoft.com up? Yep. If it is, go ahead and send a message to this endpoint out in the cloud on the service bus. And then that's what happened.
So we're sitting there. This workflow is just running continuously up in the cloud, making sure that our site's up and running. So think about that. Suppose you wanted to go build a monitoring service. Think about building out the infrastructure to keep that monitoring service up and running all the time, 24/7, maybe even distributed around the world. We just did it by sketching out that business process, which checks for it, and then starts raising events. Microsoft goes down, we send a new event.
Great. So let's just see what that portal experience looks like
Yep.
as well. So now that I have more time, I'm going to go take a look at the types that I've uploaded. And you'll see here's my running on time type. And if I go and take a look at the instances, here's one of the instances that is running. And I can take a look at the details. I can see the status, who it's running as, when it was created, when it was modified. So that's the portal way of actually managing that. Again, you can actually go back to the types, add a new type, and if copy-paste happens to be your method of deployment, you can do that as well. You can take a look at the XAML, you take a look at the rules, stick it into the form, hit submit, and hit play.
Yeah. Now, one of the ways that people have told us that they want to be able to interact with the system is that they want to be able to generate the workflows programmatically. So they want to have a tool of their own making that creates custom workflows. It can generate the XAML. It can use the web APIs, push those things up, start it. There's no need to interact with the portal at all. That's purely a mechanism to interact with it if you desire. So
Yep.
none of this is necessary. Now, did you want to show the other workflow?
I think we're good with this one.
Okay.
I want to let people ask more questions now. if they
Sounds
have-
good. So we got a question back here.
Yes, sir.
This is all great stuff. So far, all my questions have been answered except for one.
Okay.
And it goes back to the beginning of the presentation where you talked about reliable messaging
Yep.
implemented later. And when you say that, you're talking about WCF reliable messaging, guaranteed,
Yes.
on over-the-wire delivery.
So that's one thing. So yes, that's one, which is guaranteed delivery so that we can determine whether it happened. The other thing that people have asked us for is durable messaging. And by durable messaging, what they want to do is they want to send a message through the service bus, and if the receiver isn't available, we'll queue it, and then when they become available, they can pick it up at a later point in time.
Yeah, it goes with the, you said you're pending that message, throttling the receiver to actually do the pull.
Yes.
But if they go offline, the firewall goes, their firewall goes down, something.
Yeah, so
So
when? I
Okay,
will
Chris.
tell you, I'm not going to promise when. We're early.
You see
Mr.
that guy right
Clements is
there?
over there. But I will tell you this, that is the #1 request that we get from customers. They would like the service bus to be able to support that mechanism.
It'll be the next feature we work on. So I just committed him to it.
Yeah.
I write his review. See, customers told us. Any other questions?
All right, so why don't we open it up? Why don't we just first let's answer any questions on the workflow technologies, and then we'll open it up broadly.
Pass
So is
that
this
filter.
workflow? Can you address messages to a running instance? In fact,
Absolutely. So that was
the other demo that we were talking about does just that. We have, in the overview talk that we gave, we showed how Litware created a workflow that was listening for the test results. And so those messages were being sent to the running instance of the workflow. It was checking to see what the score was. If the score was below 50, then it raised another event on the service bus, which was the person failed the HR training, as Dennis is often apt to do. And there's a good example of being able to address a message to the workflow.
So yeah, and we can take. I'd be happy to walk you through the APIs to look through that.
But the basic model is very straightforward. We have a new Azure activity, a cloud activity, which is listen for a message either on HTTP or on the service bus. You use the service registry to provide a name, and then you listen on that name.
Yeah, and
So-
then further, you can actually instance the specific workflow instance. Like I can tell that you've used dubfm before. There's an instance ID that's returned when you cons up a new instance. So if you want, you can keep hold of that and send that back.
Yep. Okay, other workflow questions?
Sir, yep.
Oh, now that we're kind of done with the talk, would you mind using the mic? We'll queue people up for the mics. It makes it easier for people to hear the questions.
Actually, if we're done with the talk, could you please fill out the survey forms?
Oh, yeah, the survey forms would be super helpful. Okay, you can
You can
clap.
clap too.
So we'll keep taking questions.
Yeah, go ahead.
Right. The workflow, the hosting of the workflow is going to be the complete workflow, or is it the activities can I host it and orchestrate over the cloud?
So, sorry, one more time. I think the question was, are the activities actually hosted and orchestrating the services in the cloud?
Now, I'm asking about whether complete workflow is hosted in the cloud,
The complete workflow
Or-
system? Yeah?
can I have the activities of the workflow hosted in the cloud and orchestrate over the cloud?
You can have the activities so you can describe a workflow. That workflow has a set of activities that can orchestrate both services that are in the cloud and locally if you want, if you can expose them out.
Okay.
Does that answer your question? Yeah? I'm going to do the round robin thing. Yeah, go ahead.
There's another question maybe about internal infrastructure of service bus. Like, question is how you monitor the health of your service bus and how you protect from being abused.
So the first question is, how do we monitor the health of the service bus? I didn't hear the second question.
And how do you prevent it from being abused?
Oh, well, so there's two parts to that. One is we actually do an extensive amount of internal monitoring on, for example, on a per account basis, how many messages are flowing through and so on. In terms of abuse, there's really two kinds of abuse that can occur. One kind of abuse is where unauthenticated third parties are doing something like a denial of service attack on the service bus itself. Well, for that, we actually use the access control service to ensure that only authenticated users are able to send messages across the service bus. There's another kind of abuse that can occur, which is somebody might write errant apps that use up too many resources. you can place, we have the ability to place limits on how much traffic flows through the service bus in a given unit of time, and we can throttle on that kind of thing. But at the end of the day, if somebody is building a very high-scale app and they're using the service bus and they want to use, for example, the unauthenticated send capability, the partnership we have with them is that they're buying bandwidth. They should be monitoring how those things are being used, because if somebody DOSs them, we can't tell the difference between that and normal usage. So it's a shared partnership between Microsoft and the app users. Is that, yep? Oh.
Is that on? Sorry, is that on?
No, just say the question
and we'll repeat it.
I have to there it is. I have two questions. The first one is, what about custom activities?
Custom activities? Yeah, so custom activities is an interesting problem, because then we allow you to write your own custom code that executes in our data center. It's something that we're thinking about, but we have to make sure that we've got kind of the right security constraints there. We don't have support for it right now in the CTP. We're limited to the activities that we have. I think the activities that we've actually built are quite extensible. So we'd love to get your feedback if you don't find that's the case.
Okay. And then the other question is, what about failures on running workflows? Can you go back to a previous state or something like that, or just fail and that's it?
So I think the question is, what happens if a workflow actually fails? Is that correct?
Yeah, an unexpected failure.
Oh, an unexpected failure. If the workflow fails as a consequence of your own app, you can actually take a look at some diagnostic information through the portal. One of the things that John was talking about earlier was that we've spent a lot of time and effort to make sure that the failure isn't as a consequence of the host. So our hosts are clearly designed for scale, so you shouldn't fail at that level.
Okay.
Make sense? Round robin? There you go.
Yeah. Can we inspect the payload inside a message from within a workflow?
Yes.
Yes. So in the demo we gave on the first day, we were actually looking at the score on the test, and then based on that value, making a decision in the workflow to either raise the pass event or the fail event.
Yeah. Even today, in the demo that we were giving today, we went and pinged the site, and depending on if the site came back or not, which is data that's contained in the message, we do one of the two options.
Okay.
Definitely. Yeah.
Is there one over here? Yep.
Go ahead.
Security standpoint, do you have to do the Geneva framework, or can you just use the directory connector? Is that kind of the lightweight version of Geneva?
The Microsoft Services Connector?
Yeah.
So there's two parts to Geneva. One is the server itself. That's the Geneva server. That's the follow-on to Active Directory Federation Services. You can think of the new version of Geneva as the Microsoft Services Connector Pro, Professional Edition. Microsoft Services Connector does one federation. It's a 4-click setup. It connects to Microsoft. If you want to have federations with other companies, you buy the Pro version of that, which is Geneva. And so they use exactly the same underlying Geneva framework, and so that all works seamlessly together.
So there's also a Geneva framework, the APIs that we were showing as well. So to your question, though, can you use other APIs? Yeah, we just found, and Justin's probably the expert because I've heard him yell and scream about how difficult it is if he doesn't have Geneva to actually, parse tokens and things.
So to hook up like 4 partners together, each of us would want to deploy the Geneva server then?
Well, it turns out you've got a lot of choices.
Okay.
That's certainly an option. Everybody could deploy a Geneva server, and then you could all work together. Another option is that you could all deploy the Microsoft Services Connector and then use the federation capability that we provide with Windows Live ID to place the resulting identities into a Live ID, which can then be used to check them. So, and those are all options that have different characteristics. Most large IT organizations go for the Geneva server because they want to control their own federations. Many small businesses and even larger businesses that aren't trying to do a lot of federations use the Microsoft Services Connector because it's so easy.
Okay, thanks.
Okay.
Go ahead.
How do you have how do you handle long-running workflows? Is it handled automatically, or do you
I'll
have
let
to configure?
Mr. Workflow.
I'm not Mr. Workflow. He's Mr. Workflow. The question is, how do we handle long-running workflows? That's one of the values that this workflow service provides. Just like in WF 3.0, there's a certain set of activities that the runtime can actually reason about. And if those activities allow that workflow to be persisted or to kind of go to sleep, we'll actually put it away for you, and you don't have to worry about where. The next time that workflow needs to activate as a consequence of a message arriving or a delay kicking off or what have you, that thing comes back up on a host, and you continue to execute. So Mustafa and the guy behind him, David, would be the perf guy if you want to get more details.
Yep. And there'll be a talk on the workflow services on Thursday.
Sir?
Yep.
So I'm a little curious about, I'm somebody who's written an application in the past that uses Amazon's S3 service currently. And we ran into an issue where our application would download a significant amount of data, about a gigabyte of data in the background.
Yep.
And everything was working great until UAC, after a lot of pain, we discovered UAC was preventing what we were downloading from actually getting written to disk.
Mm-hmm.
And the application at the time wasn't smart enough to correct for that. So all of a sudden we saw a spike, and we were getting charged every time they would re-download it. And it was constantly re-downloading it because the next time the application started, it would when we went back to Amazon and asked for their help to try to pinpoint that issue, there was practically zero capability to monitor the system and all the activity. So I think I heard just a little bit ago that you said that you don't provide any kind of monitoring capabilities about usage of these services in the cloud.
So,
and I think that's important.
Yeah, we fully agree. It's very, very common as people run these services for people to write applications and get into conditions where, in a sense, their own apps are in an errant state and using up a lot of resources. So one tool that people have asked us for, which we're going to be providing, is the ability to rate limit the service itself. So if the rate were to spike, you could detect that, and it would actually shut off the ability for that app to work for a period of time.
That would probably cause more problems, though.
Well, that's one tool that people have asked us for. The other thing that we are going to be providing is extensive monitoring capabilities, so you can see what kind of usage things are having on, for example, the access control service, the service bus, what channels are being used, that kind of thing.
So you will be able to see things like
we don't have that
different
CTV.
connections, abnormal connections, or connections that are consuming way more resources.
So the vision that we kind of have for like this feature was that of kind of a cell phone bill, right? Where you could take a look and say, at this time, this service used this amount, right? So you can at least be kind of instrumented about how service.
But at the service level or the actual connection to the service level?
So the bill, quote unquote, would be at the service level, but the details would be just like your cell phone minutes. It would say, here's the connection that was used at that time.
Okay.
So that's something that we're very eager to actually release.
Yeah, I'd appreciate that. I think it's important. Thanks.
Okay, thank you.
We see those people outside?
Yeah, we should. What we'll do is Dennis and I will head over here to this other door, and we'll continue taking questions, but we should let the other people come in for the next talk.
Thank you very much for coming.
Thank you.
Appreciate it.